Welcome today to this interview with Bradley Jones. Dr. Bradley Jones is a principal consultant at Atsurgo, and previously he was the Distinguished Research Fellow in Jump Statistical Discovery, where he built the Custom Designer, a general and powerful tool for generating optimal experimental designs. He holds 16 patents for innovation in design of experiments. He is the inventor of the prediction profile plot for interactive exploration of multiple input and output response surfaces. And he is also the co-discoverer with Christopher Nachtsheim of definite screening designs. With Peter Gools, he wrote Optimal Design of Experiments, a case study approach, which won the 2000 Siegel. He's also the co-author of the book Design of Experiments, a Modern Approach with Douglas C. Montgomery. He received the Brumbaugh Award for the paper making the largest contribution to industrial quality control in 2000 and 2000. He is a recipient of the Lloyd S. Nelson Award for the article having the greatest immediate impact on practitioners in 2000 and again in 2000. In 2012, he received a Statistics in Chemistry Award from the American Statistical Association for outstanding collaborative work with a chemist, and he also won the Uden Prize for the best expository paper in technometrics in 2000. He received the 2000 William G. Hunter Award, and in 2000 he was awarded the Sewell Medal as well as given the Uden Address. He is a former editor-in-chief of the Journal of Quality Technology and a fellow of the American Statistical Association and the American Society for Quality. My God, Bradley Jones, what a resume. You are very well known in the DoE landscape, and I'm very happy that you are here today with us, with Effex, to shine your light further on design of experiments and spreading the word broader. How long actually have you been involved in design of experiments?
I started doing design experiments in the early 80s when I was working as a statistical consultant inside of a factory that did machining and welding and that sort of thing.
And was like design of experiments, were you introduced to it immediately, or like how you say you first started somewhere else and then got introduced to it?
I had a book on design of experiments that I bought as a graduate student, and I had time at the beginning of my work at the factory to actually read this book. It was a book by Box Hunter and Hunter on design of experiments. And then I had engineers come to me with problems that until they came to me, they couldn't make a good product. They had, in one case, 8 different things that they could control in the process, and they had not succeeded in ever getting a response that was what they wanted. So I tried this experiment out of the book from Box Hunter and Hunter, and it worked fabulously. And I think mainly because it was able to systematically look at all 8 factors and find a setting that would, instead of having no good parts, it made all good parts from that point on.
Okay.
So I was convinced.
And what was the thing that like fascinated you the most on about design of experiments?
I think that it was the fact that you could explore a complex multidimensional system with a very economic and efficient set of runs of the process.
Because like for people who are like to design of experiments, like how would you describe it, or how would you introduce them to design of experiments?
What I would say is that design of experiments is a way of establishing cause and effect relationships in a system or process by a systematic set of runs of that system or process.
Okay. So you have been around for a very long time in the design of experiments like landscape and ecosystem. So if we're talking about design of experiments itself, like what do you think is the biggest evolution that you have seen for design of experiments throughout the years?
I think the biggest evolution has been the use of computers, and in particular optimal design using computers. In the early 80s, there were there was no capability in a commercial sense of being able to use a computer to create optimal designs. And over the next 30, 40 years, the systems for creating optimal designs got very much faster because the computers got faster, and very much more flexible because they dealt with more and more practical problems.
Okay. And do you think, like, because when I was reading your resume, there were a lot of inventions as well on the part of design of experiments itself. Like, where do you see like still like evolution possible? Like, for instance, our OMARs designs that we added that invented at Effex.
Yes, evolution is still possible. It was funny, in the 1980s, the National Science Foundation in the United States had decided that the design of experiments was a dead topic because everything had been found out already. That's sort of the same situation that physics was in at the beginning of the 20th century. And then there was Einstein. So what happened is that the computer became a big part of what was going on and has created a lot of the evolution along with innovations from people. And I believe that OMARS designs are a new innovation in design of experiments. They are a generalization of definitive screening designs, which, well, they're clearly a strong new addition to the set of tools that a practitioner has to do design of experiments.
What do you see as the biggest added value today, actually, for our OMARS designs?
Since they're a generalization of the definitive screening designs, what they can do is they can provide more precise estimates identifying small second order effects like quadratic effects and two-factor interactions. That's their power.
So, and if we are looking then at design of experiments and then design of experiments like in the innovation process itself in companies, how important do you find it that companies use design of experiments in the innovation process?
Well, when people are trying to innovate, they often follow their nose and just do things that are ad hoc. And that process is called trial and error, and it can end up being mostly error. And so instead of doing that, the companies that make design of experiments a part of their engineering process have an ability to outpace the rest of the companies in the market because they're more efficient at doing innovation.
And like when we're talking about indeed design of experiments, and you said before, like it's so important to show like cause and effect, like in the innovation process, does it help like you to innovate then faster as well, so that when you have that cause and effect?
Absolutely. It's the efficiency of design of experiments that makes it exciting and makes it where companies that have an innovation process where they're trying to create a new product or a new system can converge on what they want faster than others.
Yes, because that's one I wanted to ask, like, with regards to design of experiments inside companies, like, when do you need to consider using design of experiments?
I think early on in the research and development process, there are times to use design of experiments, even when you're doing research in the laboratory, before moving what you're doing into the production settings. And then once you're in production, again, you need to use design of experiments to optimize the production process itself, to make it faster, to make it higher quality, and so forth.
So if you say early in the process, that means that still in the part where you're just thinking about, like, the decision to use it should be made, like, even in the in the like thought process of when you're starting to innovate, or are there other parts where you say like, okay, whenever you have this or this situation, then you should definitely consider design of experiments?
Well, yeah, when you're just thinking about something, you haven't done anything yet. It's once you have a set of ideas about what you want to do, then DOE is important because you can find out which of the things that you think might be important are actually important in making what you want.
Okay. And so we all know that design of experiments is still something that's widely underused as a methodology. And so I was just wondering like how important like is a culture for design of experiments in a company, and how would you establish it?
I think it's quite important. If management is not sold on design of experiments, then it's hard for it to bubble up to management. Sometimes when somebody does a designed experiment, even if management is not behind it yet, they see the tremendous results, and then they can become convinced of its power. But it's better if it goes top down, and if management knows what the value of design of experiments is, and also knows when to apply it and can encourage engineers and scientists to use it well.
So what would be like great arguments for convincing indeed like C-level management, and I say suppose they're not statisticians, what would be like the thing that you would tell them about design of experiments that you think will convince them?
I think that management has been convinced by various quality initiatives in the past, like Six Sigma, for instance. There were a lot of companies that tried Six Sigma, and one of the aspects of Six Sigma was design of experiments. And there were companies that bought into this methodology very strongly. In the same way, design of experiments could be marketed as a way of creating optimal processes that work well, fast. You want to go from the concept to the customer as fast as possible. So you need to be able to find out if your concept is not good, then you need to learn that early. And design of experiments is a way of establishing that. If your concept is good, then you need to work on it to make it optimal, not just good. It has to be better. It has to be better than your competitor, for instance.
Those are definitely valuable arguments to convince indeed management on using design of experiments. What we also know inside companies that statistics is still not like really well integrated often in companies. We have encountered the fact that it's most of the time like this kind of a separate group of people that do a lot of DoE or statistics for the company, but not being integrated in the processes or in the projects, or from the moment actually the project is initiated. And so I wanted to know, how important do you deem like collaboration on design of experiments, and the fact that it's pulled further inside the company also, like and that it entails like different stakeholders?
It's absolutely essential. It can't be just the domain of the statisticians. First, there are about 100 times as many engineers as there are statisticians in the world, maybe even more than that. And so it's important that engineers learn how to be competent at design of experiments. And the way that can happen is through working with statisticians, but it also can happen just by learning the powerful software tools that there are available for doing design of experiments. There are a few crucial facts they need to know about design before they start, but I think that the learning curve for design of experiments can be short. And I think that when one decides to do designed experiments, then there are many stakeholders that need to be in the room before you actually start doing a design. You need to have the technical experts, but you also need to have the operators. The people who are actually going to perform the experiment need to understand what the goal is. They also need to be made aware of what's going to happen in advance so that they can let people know that certain things are not possible. And oftentimes that happens later and it could happen earlier. When things are not possible, then you end up having to go back and redesign the experiment.
Yes, I think that's how I say, another question that I had is that, yeah, sometimes people have had a very bad experience with design of experiments. And so, yeah, I was thinking like, okay, what advice would we give people that indeed had that bad experience because indeed they did not do the how I say, the collaboration well with all the stakeholders, and therefore did not know what are the barriers that there are in the design of experiments. But maybe then combined in the question is, yeah, why is like dropping design of experiments because they deem it not good enough or like too expensive, like a wrong idea?
There's a lot of questions there to unpack. First, about bad experiences. A bad experience can happen because the set of factors that are used in the experiment don't affect the response of interest. So that's basically a negative result. You find out that nothing that you were changing to try to make things better worked. Well, that's information. You may say, well, it didn't work, but in fact, you learned something. You learned what doesn't work. And that means you need to go back to the system and start thinking about what other things that are not the things that you originally messed with would change the outcome. Another thing that can cause experiments to fail is related. It's the opportunity space for success in design of experiments comes from having more factors rather than fewer factors, especially at the beginning. So investigating more factors allows for a good result because you're operating in a very much larger space, and that gives you more opportunity. So that, and then finally, another reason why people may have bad experiences with DOE is because they, especially with continuous factors, they don't change, they don't vary them enough. So they use small ranges, and the range that they're investigating isn't covering the sweet spot of the process. They do this because engineers have been taught that all relationships between factors and responses are nonlinear. When they study engineering, they get equations, and those equations are generally involve nonlinearities. And so when a traditional statistician says, "Oh, well, you need to do just two levels of each factor," the engineers think, "Oh, well, if I only have two levels, I need to make them close together to avoid the nonlinearity," and that's exactly the wrong thing to do. So the right thing to do is to use larger ranges and then also have a third level, and that's what OMARs designs do.
Yes, I was indeed thinking like, okay, that's what we do indeed with the OMARs designs. That's the good thing. So indeed, if you then, because it's not only like the fact that they have the bad experience, but sometimes also that indeed it's deemed too expensive. And yeah, knowing now what I know about design of experiments and also how it's used in the innovation process and how it can help you to better indeed find that cause and effect, why is it often then deemed too expensive to do it? Like, where does that feeling originate, and why do you also like think it's a bad idea to drop DOE in order to, how you say, save money?
Well, you have to think about how much money you would lose if you didn't do if you did something else. Trial and error is very expensive because you don't learn the cause and effect relationships. And so you can end up going down a path that doesn't help. And then you try a different path and then a different path. And, all of a sudden months have gone by and you haven't gotten any closer to where you want to go. One reason why people may think that designed experiments are too expensive is that they try to fit very complicated models at the very beginning. And the more complicated a model is, the more runs you have to do to fit the parameters in that model. That's a fact of nature. So if you can be less at the beginning, if you can think a little bit less ambitiously about the nature of the model that you want to fit, then you can start by investigating a fairly large number of factors. And then from that first experiment, you can learn that quite a few of those factors that you investigate don't have very large effects. And so you can ignore them in the future. And then you can use an experiment that has more complexity in the factors you've already found.
So why then is it still so attractive to do either trial and error or like one factor at a time? Is it, because it feels easier to do?
People have ideas about a process before they start with it. And so they might want to try investigating what they think is going to help. And if you don't have a culture of design, then the loudest voice in the room gets to do what they want. And then, the fact that a lot of people still do one factor at a time experiments, even after 100 years of applications of multi-factor experiments, is because that has been taught in school, that one factor at a time is the way to establish knowledge. And it's a costly idea because factors often work in synergistic ways on a process. And you can't establish synergy. You can't learn about synergy if you don't have more than one factor in your study.
Yeah, and you also, of course, then have the bias of the loudest person in the room that is also involved, of course.
Yeah. So that's a problem, and that's when it's really important to have a culture of design, because the culture of design will make the process of doing design be more collaborative and not just focused on one person who thinks that they're the expert.
Yes, indeed. So, like, talking further on indeed, like that culture of design or that barrier of adoption of design of experiments by companies, that we kind of see that it's also dependent on the sector that they're active in. That, for example, like in pharmaceutical companies, they're used to working with design of experiments, while there may be like a lot of other sectors that think they are not ready for design of experiments yet. But yeah, what in your opinion is like the biggest design of experiments unexplored potential markets? Like, what kind of companies do you think would really benefit from design of experiments, but are like still not using it properly or extensively as they should?
I think that the automobile industry has in the past tried to use design of experiments, but they did it in a way that wasn't very successful. And so I think that there is a great opportunity there in automotive. Semiconductor manufacturers have used design of experiments from the beginning, and that's why semiconductors and computers are way faster than they were at the beginning, because they had to do design experiments to make that happen. So pharmaceuticals are more as an industry using design of experiments, that's happened more recently within the last 10 years. The semiconductor industry has been using design of experiments for 30 years at least. So, and you can see that from that the success that they've had in doubling the speed of computer chips every 18 months is a result of designed experiments. Another very strong use of a design of experiments was in agriculture. The number of bushels per acre has increased a factor of 100 over the last 100 years. So, and that's due to designed experiments in agriculture. And in fact, the first uses of design of experiments were in agricultural studies, started in England. I think that chemical process industries are also a good area for application of design of experiments. And it also will require some innovation in design itself in order to support that. Same thing in additive manufacturing, the creation of parts by melting a substrate and creating parts with dramatically different shapes than you would do if you were doing machining or welding or whatever. So additive manufacturing and chemical processing are another two areas where design of experiments could really create some good, powerful effects.
Yes, I was thinking about actually like the next question going about like trends and where design of experiments can also help us with the future, because what do you think on, for instance, the use of design of experiments in energy transition and climate change?
It's hard to do experiments on a worldwide basis. So climate change, though, could be slowed by finding ways to remove carbon dioxide from the atmosphere. So that's a smaller thing, but that's something that could be dramatically improved by doing designed experiments, investigating efficient ways of removing carbon dioxide from the atmosphere without using much energy or as much energy. So that's for instance one thing.
Yeah, I was more thinking like companies trying to make like the green transition, like chemical companies replacing forever chemicals, for instance, in their products, or also with regards to using less energy in the production process, because with DoE you can also like find the minimal threshold for temperature, for instance, in the production process.
Exactly. Both of those things are really good potential applications. And as people become more concerned about waste and creating products that have components that might go into the earth, create pollutants, that's something that needs to be avoided now. And at the beginning, engineers would make products that performed a function, but they also had side effects that were maybe not desirable for society. And now we're becoming more sensitized to that, and we need to develop systems and processes that don't have the negative side effects. So that's basically thinking in terms of having multiple responses, some of which have to do with making the thing that you want and making it efficiently. But then the other part is avoiding those side effects and recognizing what those side effects are.
So if you're like, I say, indeed, it's very interesting, and maybe like a topic for like an extensive other talk in how indeed design of experiments can help with making a more rapid change on with that behalf. And so there's like this other big evolution, which is AI, that's a lot more, how you say, sexy than design of experiments where everybody's talking about. And I was wondering, like, do you see, like, how you say, a link or how between design of experiments and artificial intelligence, or how even design of experiments can have like an impact on because where this is coming from is because like AI is often big data, but yeah, not always clean data, and sometimes even there's just lack of data, and so they're trying to fill it in with synthetic data. And for me, I was thinking like, but design of experiments gives you real data. What if we can use it to maybe fill in the gaps in the historical big data, or even help it to run more efficiently? And I wondered if you had some thoughts on that.
Surely. Well, first, I think that autonomous cars are a big AI project, but those could also be improved by some designed experiments. I think that AI and design can coexist very successfully, because what big data does is it finds relationships, but it doesn't show causality. So you can have a set of variables that are related to each other, but you don't know what is the cause and what is the effect. And so what AI can do is find these potential relationships that might be causal, and then follow that up with a designed experiment to establish for sure the causality. This is the way that the two areas can work together very well. There are also another thing about a lot of the AI. One kind of AI is called machine learning, and it's using very complicated computer intensive algorithms to process data. A lot of times these algorithms depend on a lot of tuning parameters that have to be set in advance of doing the processing. But the tuning parameters that work for one process might not work for another process, or for one data set might not work for another data set. And so there's a big avenue for design of experiments to be used in optimizing the tuning parameters of machine learning. And I think that a lot of people are not taking advantage of that possibility.
Yeah, I was thinking about the profiles that should be busy with that, because in the end you have like the data scientists and then you have the statisticians. And maybe like a side question towards that is that, don't you miss the statisticians in the AI topic, on being absent?
Statisticians have not gotten involved enough in the various aspects of AI. A lot of the things in AI have happened very, very rapidly, and so statisticians haven't caught up yet. But it makes for a very strong possibility space for statisticians to get involved.
Yes, and also to learn to use design of experiments to make the AI more efficient.
Yeah, the thing that you should know is that many statisticians have not learned. Design of experiments is not taught in many universities. Now, some notable exceptions are KU Leuven, where Peter Gross is teaching hundreds of students how to do designed experiments. A similar university is Arizona State University in the United States, where Douglas Montgomery has taught hundreds, maybe even thousands of students how to do designed experiments. Some students also, in a joint project with the University of Mexico, have learned design of experiments through Arizona State. So there are a few centers of excellence in learning design of experiments, but most statisticians get PhDs without having learned how to do a designed experiment. It's terrible, but true. And the same thing is also the case with engineers. Engineers do not learn design of experiments except in the rare cases where there's some professor who actually is teaching that, where it's not a requirement, but it's something that's added. Yeah, the making a design of experiments a requirement in engineering would require a change in curriculum, and that there's resistance against that.
Yeah, it wasn't maybe then another question, like indeed one might be reluctant in using design of experiments because they think that it's like very difficult, but what is actually like the minimum requirement of knowledge that you actually need to use or to understand design of experiments?
There are a few important concepts. One is the concept of a factor, which is a thing that you can control that you think might affect the output that you're interested in. The output that you're interested in is called a response. And the response should be, the important thing is the response should be measurable, and it should be related to something that either your company cares about because of wanting to improve production, or that your customer cares about because they want certain features that your product must give them. So those two things, the inputs and the outputs, the inputs, what you're trying to do is establish the causal relationship between the factors or the inputs and the responses or the outputs. And the thing that establishes that relationship is a mathematical model. So the model is in between the factors and the response. Running the experiment allows you to fit the model and then subsequently to use that model to find better operating regions. So those are the core principles of design of experiments. They're really rather simple.
For me, and not being a mathematician or a statistician, I also find the principle of design of experiment rather straightforward and logical if you like start to reflect on it. But indeed, like I still feel reluctant sometimes when talking to people that actually are in the field and need to start implementing it. And therefore, I was very interested in indeed that threshold for start to using a design of experiments. But then related is maybe then more towards like Effex. We are a new software for design of experiments, claiming that with easier graphical interfaces and also easier input models and stuff like that, we can lower the threshold for using design of experiments. And I just wondered like what your thoughts are, because you have been, of course, been an ambassador for JUMP for so long, whether there's like a space for a new design of experiments software in design of experiments.
Yes. Well, currently JUMP has the state of the art software for design of experiments. That's true. But I always think that competition is a good thing. It forces companies to innovate. And so the stuff that Effex is doing might actually end up eventually helping JUMP do a better job of making their tools easier to use. In any case, Effex has some really original ideas about how to create a little bit easier path for people to set up a designed experiment, more modern interface tools than other commercial software for creating designed experiments. So I think there's definitely there's value in what Effex is trying to do. It's because it's a new company. There is a lot of infrastructure that has to be created in order to make it have comparable capabilities. But one of the things about modern computing and modern interfaces is that infrastructure can be built rather quickly, and that means that Effex, with its plan for creating powerful software for design of experiments, can get up and running quickly, I think.
So almost at the end of this very interesting conversation is that I just was wondering, like, what are, according to you, like the next challenges for design of experiments? Like, if we look at the future, like where will be the biggest playing field, the biggest challenge for design of experiments?
I think that traditional design of experiments kind of assumes that you can set the things that you're going to control before you start running the process. But sometimes, especially in chemical processing industries, say you have a reactor, things are happening inside of the reactor as time goes by. And so being able to have factors that change over time as part of the design is a research area that where DOE could actually develop new capabilities. So the same thing is true of additive manufacturing. The things that happen as you're making a part using this technique, there can be things that change while a run is happening. And being able to accommodate that in the design is something that I don't think current software can do. So there needs to be some innovation.
So, as like the really last, like wrapping up, suppose like people have been listening to this interview and are thinking like, okay, maybe let's give this design of experiment a try or something. What kind of, how you say, motivational, how you say, speech would you give them, or what would you tell them to do?
Well, there's the book that Peter and I wrote about design of experiments. That has 10 different case studies of design that goes from very simple to more complex. Each case study describes a different kind of system or process and the approach that two consultants would make to help him make improvements. And so that's reading that book would be a way of seeing all of the different instances where design of experiments could be used, and one of them might match close enough to what you're doing now to make you think, oh yes, this could work for me. A lot of times the barrier to entry is that people in a particular business or industry don't see something exactly like what they're doing. And so there's a process of taking what you have in front of you and generating this notion of a factor and a response. That's a um, that's a that's a difficult thing, and one way that AI could be of help in doing that would be to have for any kind of business, you could maybe suggest potential factors for them that they might be interested in, because you have a library of factors that goes across industries, different library for different industry, let's say. So those are things that, another thing where AI could actually benefit. I think that I think too much has been made of the difficulty of design of experiments. They're actually not hard. And it's more that when you have a multivariable process, setting up each design run is has some logistical complexity, because you have to have everything set up the way that the design calls for. And if you make a mistake in doing that, then indeed there can be things that don't turn out well. So what that suggests is that there should be collaboration at the point of doing each run of an experiment, that where the stakeholders are all aware on a run by run basis of what's happening, and help each other make sure that the logistical problem gets taken care of.
That's a nice one to finish with, actually, collaboration as a starting point for using design of experiments. I really want to thank you, Bradley, for having this conversation with me on design of experiments. And I definitely hope we can, have another one in the future. And for those who are interested in learning more about design of experiments or want to learn more about Effex, you can always check our website, which is www, and or reach out through LinkedIn or send a direct message. And we gladly inform you about the capabilities of Effex, how design of experiments work, what we do, what even more information on OMARs designs. So feel free to reach out, and hope to see you in the future again for another talk on design of experiments.
Yeah, this was a pleasure for me. And yeah, I'd be very happy to have other conversations. It was a really interesting conversation.
You bet on it that I will definitely get back to you in the future with more questions.
Okay.
Thank you so much.
Thank you.